Hello, a warm welcome everybody. It's my pleasure to welcome you all to this webinar on deploying GraphQL services as managed APIs. I'm Naduni Pamudika, a senior software engineer at WSO2 working with the API Manager product team. Along with me, there's Hiranya Kavishani, who is a software engineer at WSO2, also from the API Manager team. Today, both of us will be walking you through the what GraphQL is and how WSO2 API Manager 3.10 version supports exposing GraphQL services as managed APIs on this webinar. Here's the plan for the rest of the hour. We will be starting our discussion with a brief introduction and then why and when to use GraphQL, a brief comparison between the REST and the GraphQL. And then we will be focusing on the need of an API management solution. And finally, we will be looking at how WSO2 API Manager 3.10 supports GraphQL, following with the live demonstration. At the end of the webinar, we will present you the roadmap on upcoming features related to GraphQL and finish it off with the Q&A session. Let's look at what GraphQL is. As a brief introduction can help you understand the details more. This introduction is not going into more details, but it covers the basic information on why it was invented and the benefits of it when building applications in the modern era. GraphQL is a leveraging API technology which declares a query language for your APIs. And the main advantage here is that the results returned from GraphQL queries can always be predictable. It gives what you request, nothing more and nothing less. As similar to OpenAPI definition in REST APIs, the heart of every GraphQL specification is an SDL, a schema definition language, which is a graph data model. And it was created by Facebook in 2012 to power their mobile applications. And in 2015, they released it to open source. And it has been revolutionized at several innovative companies like GitHub, Spotify, Yelp, and Shopify, because of its ability to make API calls more efficient, flexible, and developer-friendly. And GraphQL is typically served over an HTTP endpoint, which expresses the full set of capabilities of a service. And it is reported that Facebook has been serving thousands of client versions over a single GraphQL endpoint. And this is the specification for the GraphQL. And this is the reference implementation, which is in JavaScript. And the main thing is it supports many languages, and you can find more details at this link. Throughout the webinar, we will be looking at the same example to make it more clear for you. So this is a sample products management service. And there's a retailer who sells products. There are customers who buy product, and there are a set of products in the store. Keep this in mind as we will be referring to this example in our next set of slides. And what you see in the left side of the slide is a type system. This is the type system of the products management GraphQL API. Each one of the GraphQL APIs would have a type system similar to this. Basically, this defines the capabilities of an API. And all the types exposed in an API are written down in a language called the GraphQL schema definition language. And it's like a contract between the client and the server. And once it is defined, both the sides are aware of its data structure. There are some special root types as query, mutation, and subscription. In the bottom, you can see a query and a mutation. And we use queries to fetch data. For example, say a customer wants to retrieve a list of available products in the store, then he or she can try out a query like this. He or she can call to this all products query, and upon execution, that customer will get a list of products available in this store. This is the list of products you will be getting. And the main thing is this set of data closely resembles the structure of the query. You can see that we have requested the data ID, name, description, and category, and the response also we are getting the same set of data, nothing more and nothing less. Mutations. So the mutations we are using for create, update, or delete data. Consider a scenario where a retailer adds a new product to the store. Then the retailer can use the add product mutation, and then it will give the response with the details we asked for. For example, here the retailer adds the leather shoes product to the footwear category, and it requests for the ID and the name as a confirmation. So as you can see in the response, you get the ID and the name. The other type is subscription, and this enables servers to communicate to the client once an event occurred. This is typically implemented via WebSockets using its full duplexity support. For example, in the same products management service, a retailer will be notified whenever a new customer node is created. Now let's move on to discussing the differences between the GraphQL and the REST to see why and when to use GraphQLs over the REST. I'm pretty sure that all of you have tried the RESTful systems for years, and it would be interesting to know about GraphQL compared to REST. Both the REST and GraphQL are two ways of exchanging data between the client and the server. The REST-based approach is the traditional way of doing so, and the GraphQL is often considered as a revolutionary method to think about APIs. Let's consider the same products management example where the retailer wants to know the list of customers who ordered a particular product. If you try this with REST, you need to do the following 3 API calls. Initially, you need to fetch the list of available products in the store. So you have to call for the products endpoint, and you will see the list of available products. And I'm going to pick the product ID 2, and I'm going to fetch the customer details of that. In order to do so, I'm doing the second REST API call, passing the product ID 2 to the customer's endpoint. Now I'm getting the customer's ID as C1 and C2 for the product ID 2. So as the final REST API call, I can fetch the customer specific data, sending the ID one by one. So I'm doing the get calls for the customer endpoints with their customer IDs, and I'll be receiving the data as John and Tom. So for as you saw, with REST we had to use 3 REST API calls. So let's see how we can do this with GraphQL. The most important thing is in GraphQL, you can fetch only the required information by using just a single query. Here you need to send a big complex query to the product type with the product ID and the nested customer type. Since we need to know the names, I requested the name in the customer nested type. So upon execution, I received the response for the product ID 2 and the list of customer names. This is the main strength of GraphQL. As I explained earlier also, in the other words, we can say ask what you get, ask what you need, and get exactly that. Keeping that in mind, now let's look into why and when to use GraphQLs. There's no more overfetching and underfetching. What is overfetching? Often a REST endpoint will give you more information than what the client needs in a single request. So this is called as overfetching. In GraphQL endpoints, the client will not get any additional information than what is requested for. So the GraphQL solves the overfetching problem. Similarly, in order to cater a requirement, a client will have to call multiple REST endpoints to get all the data it requires. This is called as underfetching. In GraphQL, this will not happen since the client can request all what it wants in one go. Therefore, GraphQL also solves the underfetching problem. Then it fetch data using a single API call. REST services provide individual endpoints for each of the resources it has. And when a developer wants to collect all the required data, he or she has to send multiple requests to different endpoints. But this is quite different with the GraphQL, as the GraphQL services are exposed via a single endpoint, and it focuses mainly on the task itself. So a developer can fetch the requested data with just one API call. And it has auto-generated documentation using GraphQL, and it keeps it sync with the API changes. So the GraphQL APIs are tightly coupled with the code, and when a field or a type get changed, so do the docs. But this is different with the REST APIs, because as the developers, they have to follow a variety of documentation standards and specifications when documenting REST APIs. And GraphQL APIs are versionless. Most APIs do versioning when there's a limited control over the data that written from an endpoint. Say we need to introduce a change and it breaks the API, then we need to introduce a new version in order to cater that requirement. But this is different with the GraphQL, because GraphQL takes the strong non-versioned approach by providing the tools for the continued evolution of a GraphQL schema. And it's good for high performance. It has a high performance in data fetching networks. As I mentioned earlier, we had to do 3 API calls, 3 REST API calls to get the list of customers for a particular product. From using GraphQL, we can do it with just using a single API call. So it gives high performance in data fetching networks. And in GraphQL, once the schema is defined, the developers work on front end and the back end can do their work independently. So this provides the ability to build their APIs that are easier to evolve. This is different in REST because the front end and the back end are tightly coupled. So in order to do some changes, they have to do them in both the sides. And this is not good for complex queries, as GraphQL can encounter performance bottlenecks if a client requests for too many nested fields at once. So it is worth using REST APIs in such situations. Also, it is not a perfect fit for content delivery networks because GraphQL doesn't have the support for HTTP cache. In a content delivery network, web cache or a reverse proxy plays a major role. So it's good to use REST services in such situations. As you can see, the GraphQL is not a silver bullet where it fits perfectly for all the cases. as developers, you need to take sound judgment on when to use GraphQLs, and hope the above explanation cleared your understanding on it. So now let's move in to see how to expose your GraphQL services as managed APIs. Before delving into this, let's understand what is the need of an API management solution. As you already know, GraphQL API enables developers to tailor the request to retrieve the information they need by constructing the query request or mutation request to multiple data sources exposed via a single endpoint using a single API call. So as you understand, using GraphQL is a great opportunity for consumers as they have more power and freedom to construct complex types of queries. Even though it makes consumer life easier and more convenient, execution of such GraphQL queries introduce more work on the backend. So at the same time, it needs to handle rate limiting, authorization, and authentication problems. So for GraphQL services, it is straightforward and worthwhile if it has another layer to take care of all these aspects and manage the GraphQL service so that the GraphQL backend can only focus on its business logic. Therefore, it is important to make sure that the GraphQL services are exposed in a secured, controlled, and monitored API management environment. Let's take a look at list of features which would be ideal to have in such environment. It's good to have the first-class support for creating and publishing GraphQL APIs. What we mean by first-class support here is to treat GraphQL specific characteristics specially and apply API management to them to support GraphQL specific use cases. And it is good to have authentication and security because the APIs are mostly exposed to external users who are not a part of the system. Therefore, security plays a major role at this point, and as it is crucial to ensure that the users who access the API operations are authentic. So it's important to have authentication and security in this API management environment. Similarly, it's good to have role-based access control for each operation. Say there are operations which can be done by a subset of users in your organization. Then an API management tool should be able to assign different level of permissions to its operations of the API so that it can look into the incoming query and decide whether to allow it or block it. And it's a valuable thing to have rate limiting in GraphQL operations. There can be specific operations which can be expensive to execute. Allowing same rate limits to all the operations like them or treating all of them similarly will not be a good idea in a production system. So API developers should be able to recognize these expensive operations and should assign rate limits accordingly. And another cool thing is to have operational level analytics, as analytics allows you to have fine-grained insights about the data that is requested on the backend. Also, you can do low-level performance monitoring of the requests that are processed by your server with this. And it's always good to detect and block malicious or unintentional queries. Since the client has the freedom to request any amount of data from the server, a malicious request or an unintentional request with nested queries can stress out the server. So an API management layer can be used to protect these types of requests by inspecting whether query exceeds a certain limit or not. So the WSO2 gateway fulfills aforementioned API management requirements for GraphQL APIs. Let's look at the values that we can provide for query operations by exposing this products management GraphQL service as the managed products API through the WSO2 API gateway. Over to you, Hiranya.
Thank you, Nadune. Now I believe you would have understood why it is important to have an API management solution for GraphQL APIs and what are the different aspects of it compared to traditional API management. Let's see how we can deploy a GraphQL service on WSO2 API Manager 3.10, which offers various features to support these different aspects. If it is possible to expose GraphQL service in any traditional API management platform, so that means you can treat it as a REST API. You can expose the service as REST, like creating two resources such as get resource to expose query operations and post resource to expose mutation operations. But the GraphQL API developers would not be satisfied with these existing REST API features for GraphQL API management to work, because their main focus should be on the query operations, not the resources. Therefore, it is essential to have first-class support for GraphQL APIs to serve the GraphQL specific features. Then API developers can manage their APIs as they prefer and publish them to gateway. WSO2 API Manager Publisher fulfill those GraphQL specific requirements. First, API developer can create GraphQL API by importing its SDL schema. Once they are created, they can view the list of operations that are available on the SDL file, and also they can separately identify the GraphQL APIs at the publisher as they have been tagged with GraphQL tag. So if they need, they are allowed to download the SDL file of the API. Also, they can search the GraphQL type APIs because we extend our unified search to facilitate this. So all of these facilities actually bringing a different view for GraphQL APIs. This image displays the view of the publisher once we create the products API importing its SDL. Let's look at how we can expose this products management GraphQL service at WSO2 API Manager. Before going to publisher, I'll go into management console. Let's log in with admin credential. Sorry. Here you can see I have created two users, Alice and Mike. So Alice can act as a API developer who has been granted with creator and publisher permission. Here you can see, and also Mike who acts as an application developer, assigned both customer and retailer roles along with the subscribe permission. Now log in with Alice to publisher. Here I am providing the Alice credential. Okay. Then as a first step, I import the products API SDL to create the GraphQL API. Now I'm adding the basic details of the products API. Let's say context test version 100. So this is my GraphQL service. So as the business plan, I here select unlimited and goal. Let's create it. So once it is created, the overview page has been loaded. So it displays the list of operations. If Alice want to see schema definition of the API, she can go to schema definition and import or download the schema definition. Let's move to the slides again. Here. So when talking about the authentication for GraphQL APIs, so APIs are, they are mostly exposed to external users. In typical API ecosystem, there are at least three types of parties involved: API developers, application developers, and end users who consume the GraphQL APIs via an application. In our case, Alice develops a products API and make it available to external parties. Next, Mike has a requirement to consume that API. Then he discovers the products API and creates an application to subscribe to that products API. Finally, on behalf of the Mike, the end users consume the products API run that subscribed application by delegating the access to the application to access that API. So security plays major role at this point, and as it is crucial to ensure that users who access the API operations are authentic. Not every scenario, but there can also be some occasions where some GraphQL API operations should be exposed to the public. So giving access to anyone without authenticating to the system. Therefore, some operations may need security, some may not. So considering these requirements, WSO2 API Manager facilitates to enable or disable operation level security and also provide the several authentication mechanisms as per the requirement. So in this image displays the view of the operation listing page. So Alice can now assign the security rules for products API as she wish. Let's go to the publisher. Okay, this is the operation page. So by default, security is enabled for every operation. With the requirement, we can disable. For instance, in our use case, all products operation in products API, which retrieves the details of all listed products, should be displayed for everyone without authenticating to the system. Therefore, we can make it disable. Now I am disabling it. Okay. So here, if a particular query request include multiple operations, let's say Mike wants to retrieve all products along with the customer details, who has been ordered them, then Mike can't invoke the API without a token. So if one operation has enabled the security, it will automatically apply for whole request. So when I will save it. Okay. Now, if I'm go to the runtime configuration, I can select a single or multiple authentication mechanisms as preferred. So by default, it's enable auth protocol. Let's keep the default one for products API. Let's move to the slides. So as a demonstrated due, API developers can add multiple authentication schemes at the runtime configuration, which facilitates the selection of variety of security mechanisms such as WSO2, OpenID Connect, API keys, basic authentication, mutual TLS authentication to secure the GraphQL APIs. When talking about the authorization for GraphQL APIs, any software system like a content management system, a human resource management system. So all of those systems exist several user groups which assign for specific tasks. There can be some operation which needs to be accessed by only a subset of users in any organization. Then again, GraphQL API developers raise a problem. How can we limit the API access to make sure that only the authorized parties have the access for a particular operation. WSO2 API manager can assign different level of permission to the GraphQL operations, allowing fine-grained access control with the auth scope. So this enable the API gateway to inspect the incoming query and decide whether to go or not to the backend. So for example, let's consider simple requirement. So Alice need to distribute the privileges among the user groups to access the API. So in this scenario, we can identify two user groups. Retailers who can add, remove, see customer details, and customers who can register and order the products. So how can Alice do the access control? What about Alice can create two scope called retailer and customer, and she can create a mapping by binding the role related to that specific retailer and customer. So each subgroups, and then assign them to operations to access the operation which are only allowed for a particular user group. Let's see how we can do this. Okay. Now I'm going to create two scope. Retailer. I have already created this role. Okay. Now I'm going to create another scope called customer. Okay. So now go to the operation page. As I said before, adding or removing product and retrieving all the customer details should only be open to retailer user group. So now I'm assigning them. So remove product should be delegated to the retailer user group, and that product same, and all customer. Okay, and also similarly, adding a customer operation should be open only to the customers to register to the system. So now I'm keep the customer for here. So what about other operations? If I explain the use case, the all products operation can be used to retrieve all products details, and also product customer query operation can be used to retrieve either details of a particular product with customer details, or retrieve the list of products ordered by a particular customer. Therefore, these rest of operations should be open for both parties. We can keep them free of access. So now I'm updating the API. Okay. So once we assign them as a desired to use case, unauthorized parties never can be accessed this operation which do not belong to them. Next, move to the slide. Okay. In GraphQL, there can be specific operations which can be expensive to execute on the server, and there can be a various combination for a particular element referred to in a query. So allowing the same rate limit to all operation for or treating all of them similarly will not be a good idea. Therefore, there should be a mechanism in which the API developers can recognize these expensive operations and assign the rate limits to control the API traffic accordingly. So WSO2 API Manager allows you to manage operational level rate limits. API developers are allowed to set rate limits by individual GraphQL operations for entire API to manage the operation-based traffic. So in this image shows how API developer can assign the rate limit value for operations. Let's do the rate limiting on the products API. And here, anyone can fetch the list of products that are available in the store. Therefore, I assign the unlimited rate limit for all products. Okay, and all products operation. So both both retailers and customers have the ability to retrieve the information of the user when fetching the list of products, the details of a particular product, and the details of a particular customer. So there are multiple ways to reach the customer element. So I can assign a comparatively high rate limit on the customer operation. So here I'm going to assign 50K per minute for rate limit. And the customer registration. So add customer operation, that means will become a more frequent task, right? So therefore, let's assign a high rate limit for that one. Here I use the same 50K per minute. And but what about the adding removing products, which is an expensive task? Then I can assign a lower rate limit compared to the other operations. Right, so at product here I can assign 10K per minute, and at product also I can set 10K product min. But for the product and all customers operation may not be either expensive or frequent task, so we can assign it 20K minute rate limit. All customer and product. Okay, now I'm going to save the API. So likewise, API developers can check the relationship among the operations and decide the rate limits on the API. Now we have designed our products API according to the requirements as we discussed. Now I'm going to publish this design API. Navigate into lifecycle page. Okay. So you can see now products API is in published state, and it is categorized as GraphQL type API. And so this tag can easily identify the GraphQL APIs when the portal has a lot of APIs. Let's move on to next slide again. Know how to how consumers can invoke the API. So once GraphQL API developers publish and expose their APIs as managed GraphQL API, consumers can subscribe and start to consume it. What if there is a portal hosting and advertising those exposed APIs, including several functionalities such as self-register, discover, evaluate, subscribe, and then consume? So application developers' life become very easy and convenient if there is a portal like that. Also, let's think about a developer portal which offers a list of benefits such as viewing a list of available GraphQL APIs, selecting the APIs under different categories and view their details, and searching GraphQL type APIs, and viewing or downloading the STL documentation of an API, and rating, commenting on their consumed API. Then others can get an idea of that particular API. So not only that, facilitating a developer-friendly UI for a query tryout. So all of these features help GraphQL application developers to understand the information about the APIs and easily try out the queries and in a secured environment. So the WSO2 API Manager developer portal comes with all of these benefits. It has integrated with a nice UI called GraphQL tryout console. Let's move into the developer portal to check whether our published products API is available there. So I can simply go navigate with this. Yeah. So I have the application developer who named Mike. So now I'm going to log into the system, my credential. Yeah. So I have already created an application to subscribe with the products API. Let's subscribe with that API. Okay, and here I can click the manage app to generate the token for the API. So here I can use the scope, but for now I just generate the token. I have copied it. And if I show you the GraphQL tryout console, here you can see it, right? So this is comes with actually this all of these features mentioned at the GraphQL language specification are support with this GraphQL tryout. It has useful features such as syntax highlighting. Let's say also we can real-time error reporting. See, and also automatic query or variable completion. If I try the information of the product, you can see it's automatically suggests me to provide the information, right? Uh, so also there is a nice documentation explorer which can search with markdown support. We can see the relationship among those objects. Likewise. So and at runtime, it's this inspect the query result using any promise which resolve the JSON results. Here also you can see the explorer without we can just typing the query. We can just try out with here. Let's say, see if I need the information, we can tick the fields, right? So also Prettify can construct the query very nicely. So with along with these features, application developer can easily try out the query. Next, move on to the slide. Yeah, if I move forward, let's see how we can consume the products API with some query payloads. So here I'm going to use 3 use case. First one is to retrieve all products, and then I'm going to retrieve the customer list for a particular product, and then I am going to add a new product. So here I have already created the query for the retrieve all products. So without token, I can able to invoke this API, this operation, because we have disabled the security for all of products. Here you can see the response of the our query request. It responds with what I requested, right? So let's say what happen if I add the customer details, which I need to see the at the response. Then it says a missing credential. So without token, we can't access because security is enabled for the custom operation, right? So let's try out what if I use the token which I have generated previously. Let's say I want to see a product with ID and name along with the customer details. Yeah, so if I construct the such query with the token, now you can see it responds with what I request. There is 3 customers along with that this product who ordered t-shirts, right? So what happen if I try add the product? So that one I just copy the query. Oh, this is easy for us, right? So I'm trying to add new product. Here I can use the Prettify to construct the query. Let's say try, then it says the access token does not allow you to access, because you know when I'm generating the token I didn't use the retailer scope, right? So go back to the application and regenerate the token with adding the retailer scope. So I generate the token with the retailer scope here. Now try the same query, which is we are going to add the new product. We can get the here with the history. See, now it is created successfully, right? Now you have an idea how it works under operational security, authentication, and authorization. Similar to this, operational rate limiting is working on each operation separately. If a request contains multiple operation, it will be throttled out when an operation exists with minimum rate limit is exceeded its desired limit. So this is how we provide the value for GraphQL API operations. Next, move to the slide. If an API gateway analytics support, more fine-grained insight on the GraphQL APIs, right? So it will allow API developers to easily monitor their GraphQL APIs, how the GraphQL operations have been consumed, and understand the low-level performance of the requests that are processed by the GraphQL server. So WSO2 API managers support this platform to see operational statics on the GraphQL APIs. Let's move into see the analytics. So here I use this window. Okay, now I'm going to log in with admin credential to see the analytics on the products API. So there are 3 portals. In order to see the details of the API, I use the API publisher. So there are several widgets showing the several attributes of the API consumptions, right? So if I move to the usage summary, you can see operation details here. Operation details that are requested by Mike. These rows belong to the request that I have sent to the backend. So I think you remember that I sent the query to see all customers who ordered a particular product. So that time we consumed 2 operations, such as customer and product operation. Then it will display as a comma separated way, right? If I move in to see the API performance, this is a API latency graph, so which displays how latency happen on the each aggregated operational queries and individual operation queries that are processed by the server. Here multiple operations can be selected from the defined operation list and able to check how parameters are getting with the combination of the operation. So if I select all products, then it shows me the graph with the several attributes like response time, security, throttling, likewise. And what about if I log in with Mike to see application details? So similar to this, if I log in with Mike, it's populate me to see analytics on the application. Here, if I choose the products on the mic, then I can see the operation that invoke through that application, right? So this is how we support the analytics now. Moreover, with this, the gateway support, it has the possibility of integrating with the other analytics tools like ELK, Splunk, likewise. Move into the slide. So, meantime, we are actively working on several upcoming features which have been included in our roadmap. So, we are going to introduce subscription plans on the query complexities, which allow application developers to decide the maximum limit they need when subscribing to the GraphQL API by selecting a matching business plan. So because it is important feature to secure GraphQL service from malicious, unintentional, or poor queries. So WSO2 Gateway will block such queries against the query complexity and depth limit defined at the subscription plan. So this comes as an alternative rate limit feature for GraphQL API. Also, we are working on the micro gateway support. You know, micro gateway is cloud native API gateway that can be used to expose one or many microservice as APIs. Therefore, we will support this capability for GraphQL APIs along with the SDL file. Also, we are going to support the WebSocket subscription to support real-time communication. That is the end of our presentation for the webinar. Now, we would like to answer a few of questions related to this discussion. Please send the question that you have. We will try to choose few of them and answer before we wind up this session.
Oh, okay. We have one question saying that asking whether this is available in WSO2 2.0 version. And say, to answer this, no, we don't have the support in 2.x versions in API Manager. We added GraphQL support from 3.30 version onwards, and in 3.10 we added GraphQL tryout console and the operational level analytics features for the GraphQL. And there's another question, can we enable some kind of two-factor authentication for authentication mechanism? Yes, you can. You can do this by integrating API Manager with the WSO2 identity server. It has authenticators available for SMS, OTP, and many more.
Yeah, there is another question related to our new feature. What are the new features available in 3.10 compared to 3.0.0? Actually, not more, but the main thing is we have integrated the GraphQL UI to try out the queries easily. And also with the 3.0.0, we didn't support the operational level analytics. Onwards, 3.10, we support this feature as well. Other than that, there are no any other features we support with 3.10. Okay, that's all the questions we are going to take for now. However, we would definitely send out the answer for the rest of questions which we were not able to answer for now by the email very soon. And so we would like to ask all of you to try out the GraphQL feature in API Manager 3.10 and provide us the feedback or any issue you encounter via our Slack channel or GitHub. Also, we would like to invite you all to subscribe to our YouTube channel. You can definitely learn a lot of informative things from there. And that's what we have today for you. We hope it has been an informative and useful session for all of you. Our next webinar will be on overview of WSO2 API Micro Gateway 3.10. You can follow the upcoming webinar on our website. So we would like to thank each one of you for taking time to attend this webinar and showing interest in WSO2 technologies and helping us to build this platform. Thank you very much. Have a nice day.